All right, today we're going to be looking at 7.5, which is parts of similar triangles. In this one, we're going to see a lot of stuff we saw in the last 4 sections, where we're going to have things that are proportional. We'll set those up, we'll solve it. It's kind of like I said last time with 7.4. If those proportions are something that you're good with by now, this isn't going to be too difficult. And again, if you're not so good with that, here's at least another chance to see it. Few theorems. First one states if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. The altitudes are part of the triangle we've looked at before, and they are created. First of all, let's go ahead and draw a triangle. Altitude is made when you touch a vertex, and then it makes a right angle with the side across. So that line here in the middle, that's the right angle. And let's draw another triangle, kind of make it look similar to the one we've got. And on it, we're going to make another altitude. Let's label these. Let's say my first triangle was A, B, C. My second one was D, E, F. And on the altitudes, let's make that M. Let's make that N. According to this theorem, if I tell you the triangle ABC is similar to triangle EDF, that means the ratio between the two altitudes is the same as the ratio between any two corresponding sides. So just one of these that we could set up, and there are others, could be AM over EN, altitude over altitude, is equal to any pair of sides that you want to pick. Since I put AM on top, we got to pick one from the left one, but it could be like AC over EF. That's one option for a proportion that would work there. And like we've seen a lot already, there are a lot of different ways to set this up. It doesn't have to be just that way. You can have it flipped over. Instead of AC and EF, I could have chose AB and ED. I could have chosen BC and DF. Doesn't matter. So that works for the altitudes. The same idea also works for the angle bisectors. So for this one, if two triangles are similar, same hypothesis as last time, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So again, go ahead and draw 2 triangles with me. And if it's going a little bit too fast, you'll need to pause it. Feel free to do that. 2 triangles, kind of like we had last time. Again, why don't we just go A, B, C, D, E, F. But instead of altitudes, this one's talking about an angle bisector. To be an angle bisector in a triangle, it needs to, as the name implies, cut an angle in half. So maybe I've got this one there, and I've got this one there. And to show that those are congruent, I just put my congruency marks. And since these triangles are similar, the whole angle, angle B, and the whole angle, angle B, would be equal. So those parts would also match up. And then over here, let's put M. Let's put N. And just like last time, the bisectors, such as like BM over DN, is going to equal any pair of corresponding sides I want to use, like maybe AB over ED. And that's one possible way to set that up. You can choose any pair of corresponding sides that you want to. So as long as I know 3 of those, I can set up a proportion to solve for the missing one. And that's how that works. This also works for medians. So as long as the triangle is similar, lengths of the corresponding medians are proportional to the lengths of the corresponding sides. So one more set of triangles. So we got ones like this time. A median, as the name implies, that meant went through the middle. So to be a median, it's got to do this. Go from a vertex and bisect a side. And since these triangles are similar, the parts of those sides don't have to be equal. They do have to proportional though. So again, we'll go A, B, C, D, E, and F. I'll go M, and I'll go N. And just one example of a proportion that we could set up here. AM over DN would equal, I could do AC over CF. Just recording, so
Oh, I'm sorry.
you're okay. So an example of using this, go ahead and draw these two triangles. Since PY and OM both go through a vertex and they also make a right angle, means they're both altitudes. So if I give you really anything I want to give you here, let's say that's x plus 5. And let's say that is x minus 2. And I give you that this altitude is 16, and I give you that this altitude is 8, we could set up and solve a proportion to find x. So we're going to look at how it corresponds. This is just one option, but I could do 16 over 8 equals x plus 5 over x minus 2. And then once we get that set up, we solve it just like we would any proportion. We cross multiply. So multiply there and there. And like I've stressed a whole lot, do not forget to distribute. So it's going to be 16 times the x minus 2. So 16x minus 32. And the 8 times the x plus 5. So 8x plus 40. And then do the algebra. Move the 8x over. And we would get 8x minus 32 equals 40. And I add 32, so I get 8x equals 72. The final step, divide by 8, and we get that x equals 9. And for this case, it said get x by itself, so that's it. Now our last theorem for this section, an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. One more to draw. I have this triangle here, and I call it A, B, C. And then I draw an angle bisector through any of those sides that I want. And say I just draw the one that goes through C over here. The angle bisector, those angles are equal. Let's say that's M. What this theorem states is those two parts that I just made, BM and MA, they're going to be proportional to the lengths of the other two sides. So I could set up that BM over MA equals, since I put BM on top, I want to put the side that touches BM, which would be BC, over, since I put MA on the bottom, I need to put AC on the bottom. And it does need to be like that. They need to match up. Whatever touches this part goes with that. Whatever touches the other part goes with the other. And then, just like all the other problems we're doing, you cross multiply and you can solve. So one example of that. Sketch a triangle that looks like that, and then through it, go ahead and make this angle bisector. And let's say this is 2x minus 7. This is x plus 4. If this is 9, and this is 10, I want us to set up and solve for x. So looking at it, we've got the angle bisector, so this last theorem applies. I got some choices. I can do 2x minus 7 and put that over x plus 4. So that's an option. If I do it that way, I've got to look at what side is touching the 2x plus 7. So that's the 9. So I'm going to put it up top. And then I also look at it, since the 10 touches the x plus 4, it goes down there. And like always, hopefully you recognize immediately, cross multiply, don't forget to distribute. So you get 20x minus 70 equals 9x plus 36. Then we're solved, so move your 9x over. You get 11x, add the 70 over. You get 106. And then you would divide 106 by 11, and then just see what we get. And it looks like we'll need to round, so we'll say approximately, let's go 9.6. 10th is okay for this stuff. And that is section 7.5. So if you need to re-watch this, feel free to go back, rewind, do whatever you need to do. I know we went through that pretty quick. And then the rest of the block, what I want you to work on would be page 498, 1 through 6 all, 20 through 24 all. And then next time, which for those of you that are in class on a Friday, actually won't be until Wednesday of next week, since we don't have school on Monday, you'll have a quiz over section 7.4 and 7.5. So make sure you're ready for that. Stuff like what's been in the homework, maybe a little bit of vocab as well. So again, work on that rest of the block. If you have questions, see me before class on Wednesday.